can you talk a little bit about some of the trade-offs between lubricity and mechanical performance?
Well, not always a trade-off there. It depends which mechanical performance we're talking about. Any additive is going to potentially impact the mechanical performance. Lubricity, it really is, how does it manifest itself? Everybody has their own secret foo-foo dust to put in to achieve lubricity, whether it be a siloxane or anything that they have that's just listed on the MSTS sheet as proprietary. The level that it's in there and how it works itself to the surface. Is it semi-compatible and wants to work its way to the surface, or is it integral to the polymer chain after the processing? And does it have an effect? Well, the goal is whenever you're putting an extra ingredient, an additive into a compound, is to not negatively impact the mechanical properties. But that is something that whenever, because we'll run natural or clear materials that have no additional additives, and as soon as you start adding something as simple as barium sulfate, never mind a lubricious additive, you know that you're going to have to start paying attention when you're dealing with very, very thin wall extrusions. But it's not a one-to-one interaction. You have to look at them individually.
I mean, we're also seeing a shift. I've seen a lot of research and development projects come in lately that have shifted from PTFE lubricious liners to start your catheter builds. We're using more like 72 DP baxes with lubricious additives that are added to them from a couple different compounders that we use, and we're not able to achieve the coefficient of friction exactly to the PTFE what it is, but we're seeing that we're able to build some catheters right now in early stages. So I'm excited to see where that technology goes.
Working with the relationships we have with compounding houses and the various technologies that are available for the additives is a big deal also. I remember we were doing a tearaway sheath where we had used a siloxane in that application, and when we were looking at the tear, there was these stringers that were coming out, and we determined that was caused by the siloxane in this package. We were able to move to a different type of additive and get that removed, and that was just the technology that the material suppliers that we work closely with, identifying them and bringing them to the customers as well as the suppliers. The forefront, they can come up with solutions to help us as well.